Welcome everybody for this new X-Live webinar. We will present you how Seapix 3D sonar can help tuna fishing industry, especially to avoid bycatch and to make more selective catch decision. So we are very proud to show you as well the feature or the latest feature of Seapix. Thanks to years of experience, we dedicate software for tuna fishing industry in order to assist you. So first of all, I wanted to explain a few technical points regarding the technology currently in use on board tuna vessels. First of all, most of skipper in the tuna fishing industry like to operate side echo sonder. Side echo sonder, it is the regular fixed mounted echo sonder with a 7 degrees beam angle. The goal of that equipment is indeed to assess the tuna and to try to understand the spread in between big tuna and bait fish and small fish. The concern of that technology, there is some limitation about, say, volume coverage, as the measure is very located and limited to that volume. We can evaluate it at 4,000 cubic meters at 100-meter range. So it is a very small part of the whole shoal. That's a technology in use on board the tuna vessel. Second technology in use on board the tuna vessel is the omnidirectional sonar. It's very, very interesting for long-range search, omnidirectional search around the tuna vessel, of course. But the concern here is the coverage, the volume coverage, depending on the tilt angle. So it means to control the whole shoal, skipper has permanently to tilt down, tilt up his sonar, and when he tilt down, he cannot recover the fish over, and vice versa. He cannot always control the fish down when he's trying to detect near surface. So that is a concern, because to make a right decision to catch a tuna shoal, he has to evaluate the realistic quantity of fish, and also he has to understand the behavior of the fish, and especially how deep is the fish and how fast the shoal changing layer and depth. In terms of volume coverage, of course, it is much bigger than a classic echo sonder, as we saw before. It is a 65,000 cubic meter. But of course, indeed, it is not the whole tuna shoal under account, taken in account in that technology. So we wanted at XBlue to provide an innovative solution to increase that volume coverage. By increasing volume coverage, skipper can have better information and take right decision. How to do that? We developed Seapix. Seapix is the 3D volumetric sonar. This one is based on vertical beams and horizontal beams with very narrow beams, reaching a total of 256 beam per swap. So total is 512 beams. And this volume allows to have a perfect control in real time of everything from surface to down. So the operative range is 400 meter and 400 meter depth. So it's like a half sphere from surface to down. And as you can see, the figure is much higher than now about the volume coverage compared to classic regular omnisonar and echo sonders. That's a key point, and that's a point number one. It's volume understanding, volume coverage, to have a better understanding of the tuna shoal. But also we wanted to improve the understanding of the fish itself. So in order to avoid bycatch, that's the goal of the product today, is to allow capability to select fish. And to do that, we develop very narrow beams inside that volume to discriminate thanks to narrow beams. And then the resolution is very high. In addition to that volume coverage of 4 million cubic meters with one head, Seapix is now capable to form a network of several transducers that we call a dual system. And then any tuna vessel can have one or two sonar head like that. And in that situation, we control the full shoal, the whole shoal, the entire shoal from starboard to port and also from surface to down. So then we cover 240 degrees azimuth by 400 meter depth in real time. And it is, I would like to underline here that point because it doesn't need any tilt adjustment for the skipper, which is crucial when is rushing and he has to take a decision quick at the bridge. So that is a technical point. Number one, we have to keep wide control on what is going on around the vessel. There is another point, which is the resolution, as I said. The point number two is resolution. In order to do a classification of tuna fish, we have to go to the signal, to the individual tuna signal, TS. TS is a target strength. It is a response. It is the echo, acoustic echo on fish body. On a regular technology, echo sonder on a side, 7 degrees beam angle. The tuna fish in the resolution cell is not measured individually. It is a global assessment and the backscattering, acoustic backscattering of several individuals. That is a concern in order to estimate the right TS value. The resolution cell is up to 8 cubic meter at 100 meter distance always. So it is a very wide 3D pixel, if you want to call it a 3D pixel. It's we call voxel. And with Seapix technology, we reach the goal to reduce the beam to 1.6 degrees instead of 7. We reduce to 1.6, and then we are able. Seapix is capable to recover every single tuna individually, and then the TS measurements, backscattering of the body, is much more accurate. That's a key point. That's a crucial technological point to understand how and why Seapix can bring more information to the skipper, to the tuna vessel skippers. So the backscattering can be analyzed like this. It's very known on Seapix system. We can have from a weak echo, small pelagic fish like anchovy, like sardine, to the biggest tuna fish, and even inside, according to the related to the tuna species, we can distinguish big and medium and small tuna. That's a ranking very known now on a Seapix system for skippers. So based on that principle, we are able to discriminate. So more practically, how it works, I want to present you the operation mode. Seapix come to the skipper with operation mode, pre-program operation mode. It is possible, of course, to tune every mode. Here it is an example of several modes for a single head system. Down it is for dual heads system. So the principle is for every one we can have horizontal 120 degrees azimuth sonar forming. Meantime, we can have also echogram inside, and also we can form vertical sonar views. So there is many combinations. There is no limitation to imagine a combination and sonar mode that the skipper can tune himself and back up as his favorite operation mode, depending on the fishing stage. So in details, we have a capability to, for every single head, can be port and starboard, or only one on port, for instance. The coverage, azimuth coverage, is 120 degrees. The vertical sonar volumic coverage can be from 1 degrees to vertical to 90 degrees. In that example, it is an example with 30 degrees tilt. So we cover a layer of 30 degrees tilt real time on 120 degrees azimuth. And as well, we can form echogram from the sonar, or from the horizontal sonar, or from the vertical sonar slice. So there is no limitation to create echograms from any sonar views. The MMI, how it is on the screen. On the screen, of course, we recommend at least 2 screens, and 4 could be the best. On the screen, you recover here sonar swaps. The sonar swaps we had here is presented here on the middle, here, with vertical, horizontal, 1 vertical, 2 vertical, 1 horizontal, 2 horizontal. You can have more. There is no limitation as well. From that information, from sonar sources, you can draw echograms from the vertical, from the horizontal beams. You can adjust the range. So for tuna vessel, for tuna fishing, we always set up at 500 meters. And that's it. And in addition, we can propose high resolution, up to 8,000 point resolution zoom, echogram zoom. So it is unique on the market to reach 8,000 sampling point on every single beam of 1.6 degrees. So the distance in between 2 pixels here is only 7 centimeters. So from 7 centimeters, that's very, very high resolution in the whole volume. So, and the last part of Seapix is a presentation of a digitalized biomass detection. That means every individual detection, the individual fish detection we have on the classic acoustic presentation is converted as a digital fish, let's say digital fish, digitalized fish, with 1 point per fish, with 2D mapping, that's like a sky view, and 3D where you can move around the boat to understand where is the fish and how deep and how it behaves and so. And color coding according to the class of tuna. We'll come back on that. So another key feature that Seapix can offer now on tuna fishing is the capability to set up the echogram angle and direction, tilt or direction from any swaps. Can be horizontal swaps with angle, or can be on inside the vertical swaps. Here it is an example with a video. That is a tuna fish you have here. That is vertical echogram 1, vertical echogram 2, horizontal 1, horizontal 2. So horizontal means that is the history of that we detected on the side here, and vertical echogram are the history of what we detected from the vertical sonar swaps. In practice, by playing with the echogram, inside the echogram, every echogram has a menu. Inside the menu, we can go to the setup, and the setup, we can play with the angle and direction and opening of the echogram you wish. And then when you change the setting here in live, you have recalculation, reconstruction of the echogram. That is very powerful. That means now that we see is not that we had before because of the orientation. Again, now we enlarge the beam, and you see here there is more dense data available on the screen. Because as I said as introduction, Seapix gather everything we have in the water column, and then it's a matter of to select it and to show it by Skipper to adjust the right angle to show that you want to see. So it is a very flexible and very powerful for tuna fishing. And for instance, I underline that is a way. That's a good way to draw a very narrow echogram sector close to the surface in order to detect fish. This fish is just below the surface at maybe 2, 3, 5 meters below surface. So that's very, very narrow, and this narrow beam is capable to bring very defined detection on tuna. To explain how we process data, you understood we have a real-time assessment in the whole volume with a, let's say, regular sonar pinging transmission, hydroacoustic transmission in the water. That's good, that's calibrated, but we wanted to provide Skipper with more easy to understand data, especially to classify fish and especially to understand the quantitative estimate of the shoal. To do so, we digitalize every single detection in the shoal as individual point, individual detection. For everyone, we have the intensity, the backscattering on the body, acoustic backscattering. Of course, that's the main metrics we want to have, but it is correlated with the geography in 3D. That means for every single point here, we have latitude, longitude, depth as well. We know exactly where is the point, where is the fish, and its TS value. So this precious information is gathered in a database in the software, and at that step, Skipper can request make a selection inside the shoal to evaluate the quantity and to evaluate, let's say, TS distribution. I would like to say it can be correlated to weighting distribution or sizing distribution or species distribution. An example, it is an example here of free shoal swimming along the boat, and the vessel, the skipper tried to be in standby and having the same speed as the tuna to measure it and to understand the shoal before to take a decision. In that situation, Seapix provides a whole detection from surface to down, as we explained, and everything is detected and processed in real time as the spread in TS distribution between the stronger echo, smaller echo. So in a red, we classify it as a class of over 60 kilo tuna, for instance, and the blue one are identified as a smaller fish below 60 kilo. That's just an example. That's the real data. You should organize class for over 100 or over 90, over what you want. So it is a matter of calibration in between your catch and the identified signal response in the TS scope. So that is an example of a free swimming shoal beside of the vessel. Of course, the total amount of fish here, total detection, individual detection is shown here. More than, in that example, it's a real example of more than 3,000 individuals. Then skipper can make a choice to catch this part, or if the shoal is split in two parts, he can make a selection. For that, we have a special feature. This special feature is a virtual scene selection. So in that situation, skipper is about to take a decision. Shoal is going to be more dense, more concentrated, and starting to have some such rotation and more easy to catch in a concentrated close to the surface. And skipper can make a selection with a tool the 3D tool, you can select that volume and ensure that the part of the shoal you want to catch is selected, and then the calculation is based on that selection with the same capability to discriminate the spread in TS values, so spread in different class with the TS distribution, based on TS distribution, and then the number and the percentage per class. So that is a tool for sailing. And from sky view, you see the vessel track here, the biomass selection here. That's a swaps coverage here. That's a range of 400 meters on that picture. That's 400 meters here. So the skipper did select a seine tool. Usually the idea which is smart is to select the length according to the seine the person length, and then he knows about what could expect to catch if he shoot here and come back here to catch the fish, and he has the number selected in that volume. As you understand, in 3D view here, we have sonar signal projection in 3D, that every single tuna is responding here in yellow. And then you understand the benefits to digitize this information in live as fish point here, which is more easy to understand, to evaluate realistically. And benefits of that is as well, as you can observe here, there is no vessel wake. There is no vessel wake. We have only fish detection, because the fish detection is calibrated and the vessel wake is not responding in that tuna range. So it is, let's say, easy by Seapix to eliminate and to clean the picture, the 2D and the 3D picture, to keep only the wanted fish targeted by the skipper. So if we observe now some fishing example, I want to show you approach on a free shoal. That's the first example I wanted to show you today. This one is the way to approach the shoal and the understanding of the behavior. We see clearly here that the skipper been close to the shoal and had avoidance effect from the tuna fish, and then that's a good information for him. He was just observing and thinking about to prepare a catch stage. Step 2 in that story, it is then he came back to the shoal to see how it behaves, and it seems to be still stuck here and now being more concentrated because of the maneuvering of the boat, of the vessel. And last stage to understand well the process is you see the behavior of the boat and the behavior of the tuna, and even more concentrated here. It's a best preparation for skipper to be ready to shoot the net on a dance. The vessel is making shoal more dense, even more dense, by turning around and observing it on Seapix. So shoal behavior is a great value for skipper. During this crucial approach stage, it is complicated to take a decision, and depending on the behavior, and he has a clear view, and we can see history of displacement of tuna. The length of history can be adjustable in the software. This example is another example on free shoal swimming approach. Then we have the always vessel track here. You can observe the vessel where here before to come back to the shore. And as I said before, there is no vessel track here, vessel wake here. It's very clear. This time the skipper has not engaged the seine selection, just keeping all detection available in that 2D view. So you can see you have detection here, we have detection here, or backstage over there. And you can also see that the detection can be possible from below the keel to horizontal on the side of the transducer. So there is no need of vertical sonar with Seapix. Having a look on the video. So we approach to the shoal, and the very important feature is the capability to understand that echogram with fish, the analysis. We'll come back on that. Here, this picture is very interesting. You see that is a surface line. That's a water surface with a vessel here being on site. That's a vertical sonar view. This one is a top view, or more regular view from the sky, from top view. And you can observe individual fishes with the same resolution, whatever you are here. If you are here or here, you have the same size tuna spots. That is the value of Seapix. And here, from surface, you are able to understand how deep is the fish. The 20 meter is here. So let's say we are talking about 20 meter is there. We are talking about 10 meter depth of the tuna just below surface. That's the most complicated condition to detect clearly fish. And you see that thanks to the resolution of narrow beams pointing to the side, Seapix is capable to recover fish very close to the surface. That's a very good value. Now, if we continue the video, you will see the fishing scene. On board that vessel, there is also regular sonars like this. So you can see the tuna catch, the tuna detection. You can see the vessel wake and noise. And you'll also see other sonars. And come back to Seapix, you see the resolution compared to the big ball, red ball on a regular sonar. Then skipper can really understand the quantity, if the concentration, the behavior of the fish in real time. And playing, if he has time to play with the 3D, can change the point of view. And here, he can also observe in real time the calculation, the percentage calculation in between big fish and small fish. So that is very powerful in life. There is nothing to operate on the software to obtain that information in real time. So the only thing needed is to have a good screen and at least 2 displays to take advantage of all features of Seapix. So I wanted to propose you also another example. This example is not a regular fishing, tuna fishing. It is a very special example, but it illustrates very well the capability of Seapix to discriminate even in shallow water, even in quite good long range, complex situation. I explain. We are talking about tuna farm, tuna cages here. That's the tuna cages. And inside tuna cages, there is some stock of tuna. They farm the tuna. That's a red tuna in the Mediterranean Sea. And the goal of the testing here was to have a look and to measure the quantity of tuna they had in the cages. So it is a more constrained condition than the normal fishing operation for tuna, but we'll see that. So the tuna cage, dual system running with a cage on the starboard here on the sonar view, and here we come on the 2D and 3D processing with the calculation of the spread in tuna. You can observe the 2 antenna, one head on port, one head on starboard. So for the moment we had a cage on starboard, 3D view with the cage and cabling of the cage and everything. And then now the skipper will select the spotting the content of the cage with the virtual scene selector. And virtual scene selector will show us the amount and calculate only that the skipper wants to select. So you understand how it is crucial to be able to select the biomass we want to calculate. It is similar as regular scene situation. In the net, you can also use this function. It's very powerful. If we continue the video, we'll see now the spotting, skipping only the content of the cage. You see the cage in the sonar presentation with the biomass inside in real time. The range is about 200 meters on starboard at the moment. The water depth is only 40 meters, water depth, and we keep a very clear view of the cage and content in biomass count inside the cage. So that is a good illustration of what Seapix is capable to do on counting and biomass extraction, which is very, very, very challenging for hydroacoustic technology. Demonstration of the resolution. The next one, back to tropical areas, tropical tuna, Indian Ocean. We have a typical layout for large tuna. What we have? Remember, we have vertical sonar view. We have a horizontal sonar view. From the horizontal, we draw here an echogram on the side. That is an echogram just below surface on the side. On this echogram, we see bait fish close to the vessel, and they have some tuna, consistent tuna shoal, a little bit more far at the moment at a 200-meter distance about. And that we have on the left here, it is a vertical view sonar with echogram. So we draw two echogram, one echogram close to the surface, about here, and one echogram containing the rest of the water column. So then the skipper can understand easily what is coming on surface, what is coming deeper. And as well, we provide zoom here, close surface, and zoom here, close surface, but on the side. So as a movie, as we said, so there is horizontal view with a zoom, there is a vertical view and vertical discrimination of the seine. That is in the net now. In the net, you see tuna fish here swimming. There is tuna close to the surface. Surface is there, so it's on surface. The range is 300 meters at the moment. And in the net, in that net, we can have a detection here from the vertical. From the horizontal, we can observe some bait fish in the zoom. So it's very scattered bait fish, and you see the distance in between the bait fish. The blue color, it means it's related to the TS strength, and then we can observe very clear picture in the net. That's the net profile. That's the bottom part of the net. Here it is the top part of the net. It's like that. So that's the net. The vessel is there. There is a net, the bottom part of the net, and the highest part of the net here, which is that part. And over the net, inside the net, a shoal was swimming. Here it is a shoal of tuna swimming close to the surface, quite far from the boat, inside the net. And then by using the zoom echogram, high resolution zoom, up to 8,000 points here, we see individual tuna inside the net. So at least graphically, we are able to distinguish by experience what is dense tuna and what is some light bait fish echoes. So thanks to the zoom, we go to the individual bait fish here and individual tuna as well. So it is tropical tuna. That's a acoustic view. Of course, there is another screen beside of that one, and on the other screen beside of that one, the skipper has a 3D view live with the sonar projection of the net, of the detection, shoal detection. As you can see, there is a fish here moving and extraction processing, and then he has a complete follow-up of the hauling stage, following and controlling tuna behavior. You can see a tuna moving in the net, how deep it is, and the quantity of tuna fish inside the net. And in that story, the catch was declared by the skipper was 620 individuals, and we had measurement around 580. on Seapix. So it is quite accurate and very graphic and very easy to use without any action, any skipper operation on it. So it was a mix of yellowfin and some such a bait fish inside, but mostly yellowfin. So how it is installed on board a vessel? It's not complicated installation. You have the transducer. Of course, that's a dummy one. I'm not very powerful, but it's normally 60 kilos, so I can play with it here. So that is true. Is we have two line of element, 256 beam, 256 beams, and we like to, if we consider the bow in your camera side, we can consider that the installation has to be 10 degrees tilt on the side, and it has to be from 0 to 30 degrees ahead to the bow. Especially for a dual system, we like to have a dual system. Then you can have 30 degrees, then you cover from bow to 120 degrees on a port azimuth, and the other one here will cover from the bow to 120 degrees on a starboard side as well. So that's installation we used to do. And on board vessel, it is like this. So one transducer below the hull, one interface box in the sonar room, and then we have a network, Ethernet network to the bridge with two computers and at least two or ideally 4 screens to display it. And the gondola arrangement, the hull housing can be like this. Here it is a perfect case of empty keel. There is a room for that. That's perfect. 10 degrees, as always, 10 degrees forward. This one is an adaptation of refit of the old vessel. 20 degrees here, 10 degrees here, 30 degrees ahead here, and this one is just below the thruster. And obtaining very, very good performance. This vessel has extremely good performance. So the key is to ensure good flow displacement over the transducer, no turbulence, as usual, as any hydroacoustic system. So it is an example of very good installation, working very well. So it is not complicated to install. It's about similar as any big sonder transducer installation, in fact. To conclude and to be not too long, I would like to conclude by telling you Seapix is really capable to improve the understanding of the shoal. Two main value: volume, wall volume around the boat, high resolution, that's unparalleled resolution on the market. We are talking about 0.6 cubic meter 3D pixel instead of 8 cubic meter. It's a huge difference in terms of quality as measurement and capability to distinguish fish. That's a very important point. And as we control the whole shoal, even with only one antenna, it's fantastic. So two is perfect, of course. But we can control, understand, skipper can understand how the tuna behave. And also, skipper can be really warned about intruders like shark or dolphin. And the idea is really to, by following information from Seapix, given by Seapix, to reach a goal of sustainability, while skipper can still improve their profitability. That's a way to reconcile both aspects of fishing. It's a case for tuna fishing, but also that's a topic we speak often for other kind of fishing. So feel free to contact us for more information. Meantime, now we move to a question. So feel free to ask a question now in live. We can reply you. So I have a first question from John. So what is the typical range obtained on a tuna shoal? Okay, so that's an important question. As I said, we are able to thanks to the powerful antenna we have, we apply 4 kilowatts in very narrow beams of 1.6 degrees each. So the energy is very concentrated. Even we operate high frequency, we obtain long range detection on tuna, and the typical range on tuna is 500 meter. I would like to say 550 meter, but let's say officially 400 meter, even very close to the surface. That's a good question. Yes, second question I'm reading now. Why the vessel wake is not visible behind the vessel? That's, as I've explained, it's important feature. It is because of course, Seapix is capable to detect everything. If you want to see vessel wake, you can see it. You can see it, of course. Because it's detected, it's reflecting. But imagine you have the vessel wake here. Your Seapix beams is capable to hit the vessel wake with the first beam. The second beam below will pass below the wake and will be able to recover your fish over the wake. That's a very good feature. And the wake itself, if you don't want to see it on the screen, you can filter it by just applying the processing of the biomass. And the biomass doesn't respond as a wake. Yes, can we detect under the vessel? Good question. Remember that we have 120 degrees beam angle, so it means not only on the side but also below the vessel we are capable to detect. And the angle from the transducer is 120 degrees, so from here to vertical to the surface. Of course, we don't take care of the birds over the surface, but it's up to surface. So there is no matter of to detect below the keel. On the 3D map, how long we can visualize the history detection? History of detection, if I understand well the question, is that we can observe here. So that presentation can keep the history up to about 2 hours. In fact, it is not a matter of time, it is duration, it is a matter of quantity of detection. The system, at the moment, as is today, is capable to process up to 200,000 individual detection. So it's for tuna fishing, it's about 2 hours, but could be improved later on software, and will probably rise in capability to keep the history longer time on Seapix. What is the maximum speed allowing good detection, optimum detection? First point is to have good installation, means good no flow noise over the transducer face. That's installation. But if we have that, we have no limitation, according to experience we have on many vessels, no limitation. And we have several customers, skippers, approaching tuna shoal at more than 12 knots without any lose of detection, less detection than when the vessel is just stopped. Yes, can a single head Seapix can be changed and updated as a dual system? Yes, of course. Yes, of course. It means a vessel can start with one antenna on the side and can be upgraded with one transducer more on the starboard side or the opposite, and plus a computer, and everything is plugged to the same console, and the control console, the software here, manage both antenna as single system. So dual antenna, but it keeps a single visualization and software to handle the system. Yes, I have another question regarding, yes, that's a very interesting question regarding the capability for Seapix to be operated for scientific purpose. First of all, very good question. First of all, I want to say that any Seapix is calibrated from factory. It means one vessel or another vessel will have exactly the same capability to detect and to classify fish with the same response. That's point number one. But more than it, we provide for scientific use in situ calibration facilities. That's a special software module, including in situ calibration, including post-processing data, because scientists need to post-process data recorded by Seapix. That's a possibility to record all raw data, not only the process point, but the data from the hydroacoustic signal with all the setting of the system and so on. It makes the ACK format and the EcoView data format as well, EVD format, plus the calibration, in situ calibration with the tungsten fair. The scientists used to move in front of the transducer to calibrate it. So that's an optional pack, and any fishing version, Seapix mounted on a tuna boat, can be upgraded as a scientific system. So it's a good opportunity. That's a good question, because it's a good opportunity to share that rich data, accurate data on a side, and it is about unique data on the market, and should be a very good opportunity for scientists as well to take advantage of opportunity platform with tuna vessels. For the moment, yes, I have a last question. How much time is needed to evaluate tuna quantity? Yes, depending on the range, depending on the time velocity, time distance velocity for the acoustic hydroacoustic sound propagation, we can consider that the whole volume at 200 meter distance, this whole volume at 200 meter distance is taken in count in about 2 seconds. So it's very fast, and it gives it provides skipper with a real figure of the shore behavior and the quantity in, let's say, about live. 2 seconds for skipper, it's about live. So no more question for the moment. Thank you for attending at this X Live for tuna fishing industry. We are very pleased to welcome you today for that presentation. Of course, there is many other topics to discuss with you, and we'll be very pleased to do it as soon you want to email us or contact us by mail, by phone, as you want. We will be pleased to send you the video link to watch again that seminar, and feel free to take advantage of the powerful tool as Seapix to improve your catchability and to improve as well your compliance with rules. And good luck and have a good fishing. Thank you.